Suppose you're asked to find the logarithm of this number 30.82. The characteristic of this number is going to be 1. How do I get the 1? If you express this number in standard form, it's going to be 3.082 times 10 raised to the power 1. This number right here is your characteristic or your integer value. So you put 1 here, and then you can go to your table and look for 30 under 8, difference of 2. Let's do that right away. So I come here, I look for 30, I find 30 here. I check what the value of 30 is under 8. Under 8, I find it here, and it says this is 4886. Now I check, there's still a digit remaining, so I check the difference under 2, and I have 3. So I'm going to add these numbers together. I'm going to have 1.4889. Therefore, the logarithm of 30.82 is 1.4889. Let's take a look at another number. Suppose we are given the number 2941. If you express this number in standard form, you're going to have 2.941 times 10 raised to power 3. Therefore, the log of 2941 will be 3. You're going to take this number here as your integer or your characteristic. So you're going to have 3. Then you go to your table, you look for 29 under 4, difference of 1. Let's take a look at that. 29, here is 29 under 4. Here I have this number 4683, difference of 1, which is 1, and I add 1 to it. So I'm going to have 4864. Therefore, the logarithm of 2941 equals 3.4684. Let's take a look at one more example. Find the logarithm of 76.7. How do I do this? Express this in standard form. We're going to have 7.67 times 10 raised to the power of 1. Therefore, the log of 76.7 is equal to 1. And I head over to my logarithm table. I look for 76. There you go. 76 under 7 here. And this gives me 8848. Now we don't have any difference to look for, so we leave it at 1.8848 as the logarithm. Another example, we have 8.04. Now express this in standard form. We have 8.04 times 10 raised to the power 0. The decimal point is not moving anywhere. Therefore, the first log 8.04 will be equal to 0. That's taking this number here, 0.80 under 4. Let's look for 80 under 4. 80, here it is under 4. We have 9053. 9053 as the log of 8.04. I hope we all understand this. If you have any questions, you can leave it in the comments below. Thank you. Okay, now let's see how we can find the antilogarithm of numbers. Basically, we are changing logarithm back to natural numbers. Let's look at this number 1.8848. How do we change this back to a natural number? Now we take a look at these figures here after the decimal points. We have 8848.8848. You look for .88 on the antilogarithm of numbers. Here is .88. I found it here, squeezed in here. Under 4, and I find it here. I have 7656. 7656, and I have a difference here. So I look for .88 under the difference of 8, which is on here 14, and I add it to this number. Now 0767. So I get this number 7670. But I have another integer here, which is 1, and that gives me the position of the decimal point. Usually you start counting from the first number or significant digit, the first non-zero number, and that is 7. So I move forward once because I have 1 here. I move this decimal point forward once, and then I have 76.70 as the antilog of this number. Let's take a look at another example to be clear on this. If I have 2.4889, how do I find the antilog of this number? Again, I consider these numbers here. 0.48. I look for 0.48 on the table. 0.48 is here. Under 8, I have 3076. 3076. Now under the difference of 9, I get 6. 6 here. I add it together, and I have 12803. Now where do I place the decimal point? We look at this number 2. Yeah, it's safe to assume that the decimal point is here, and then you count 2 forward because it is a positive number. 1, 2, and it lands here. So your number becomes 38.2. You have 308.2 as the antilog of this number here. Gives us the answer. I hope we all understand this. If you have any questions, you can leave it in the comments below. Thank you.